Good morning, everyone. Welcome to ICTC conference, and my conference paper title is Feature Vector Extraction Technique for Facial Emotion Recognition using Facial Landmarks. And my name is Alvin Paulus. I am a researcher from Kembuk National University, Daegu, South Korea. So during the presentation, first I discuss about the motivation of this research and why we need facial emotion recognition and the application of facial emotion recognition, and followed by we discuss a small introduction about this research area and the necessity of this research area. And in this paper we proposed a feature vector extraction based FER system, and after that we analyzed the result and we did some experiment and we compare our proposed system with one conventional approach. Finally I conclude my words. So when we start with our facial emotion recognition, the conventional existing systems use direct facial images from camera as their input and train the model and classify the emotions. So when we consider the existing systems, the training models with raw images have the lack of features, and the model is face some difficulties during the classification times. So and also the other one is the system requires large amount of data samples for training. That is also a challenging task for facial emotion recognition, and the facial images are not free from noise. So the background noise existing the facial images creates some misclassification results. And also we require a strong image pre-processing technique for before training the facial images, before training the model. So to address some of these challenges, we proposed a feature vector extraction based FER system with 99.96 classification accuracy. So when we start with the facial emotion recognition, FER is used in autonomous driving system, and when we consider autonomous driving system, the FER monitors the mental condition of the driver. So when we consider the FER system, the system classify the driver emotions like happy, sad, anger, surprise, disgust, fear, or neutral. So the classification results play a major role for the safety of the car. So during the self-driving time, if we know the mental conditions of the driver, it is easy to avoid the collisions, or we can reduce the occurrence of accident. So the existing FER approaches use raw facial images. So when we consider the raw facial images, it needs a large dataset and lack of features for training and poor classification result. So to enhance the system performance, so to address some of these problems, we propose a feature vector extraction based FER system, and the system achieved a classification accuracy of 99.96% with a model loss 0.095. So here is our proposed feature vector extraction based FER system. So we start with our FER dataset, and from the FER dataset we do the data pre-processing. So the key idea of our proposed system is we extract the facial landmark and the raw pixel values. So we do a foreground extraction techniques for our raw images and remove the background noise and extract all the facial images, and also we add the facial landmark information. So the feature vector extraction block combine the raw pixel values plus facial landmark information together, and this the output of this feature vector extraction is used for training the model, and we used a ResNet model as our deep learning model, and the model classify the user emotions: surprise, sad, neutral, happy, fear, disgust, and angry. So for the pre-processing we used our previously proposed system. It's called fit machine. So the fit machine do the cropping and resizing the images and make the images suitable for model training. So here is our architecture of fit machine. So for more details about this fit machine, please refer to our previously published paper. So after the fit machine, the input is like compatible to the model with the resize images. Here is the ResNet architecture used in the proposed FER system. So the ResNet model parameter, we consider the input image size as 48 by 48, and the input image size for conventional approach is 48 by 53, and the number of channels are 1, and optimizer we selected as Adam, and learning rate we defined as 0.02, with the batch size 1.28, with the number of epochs 25. So here is our result for the facial landmark detection and foreground extraction. So our system together identify the user facial landmark plus the foreground extraction images. So the input of our model is the features from facial landmark images and features from the foreground extracted images. So here is our experiment result and analysis. So the left side is our proposed FER approach, and the right side is conventional FER approach. So for the FER approach from our proposed idea, we can see the classification result is far better than the conventional approach. So in the case of conventional approach, we use the direct raw images without any pre-processing techniques, and also our proposed approach achieved better accuracy and least model loss as compared to conventional accuracy and model loss. So next is our performance analysis. Like from the previous result, we summarized our accuracy, precision, recall and F1 score for proposed approach and conventional approach. So the proposed approach achieves 99.6% of accuracy as compared to conventional FAR approach, which has only 96.95% of accuracy. And also in the case of precision, recall and F1 score, the proposed approach shows better results than the conventional approaches. In the conclusion, in this paper we proposed a feature vector extraction based FER system, and the proposed approach shows a 2.65% of model accuracy improvement. The proposed system effectively utilized the landmark information and foreground extracted images, and together these features the FER system improved the performance. And in the future work, we consider like facial heat maps to enhance the performance. So facial heat maps can give more features to the model, and this information can improve the system performance. Thank you for your attention.